This is a tutorial of the NeuroGuide software that is used to import EEG and evaluate that EEG, and especially powerful to be able to only select artifact-free data and reject artifact. Step one is to scan through the entire record. One must always visually scan every record before and after artifact rejection. In this case, I'm using the wiper at the bottom of the NeuroGuide display, showing that there's 3 minutes and 48 seconds. There's some artifact near the end. I can click the home key to go home. I can click the end key to go to the end of the recording. It's important to go to the end of the recording to determine what the length of the recording. If it's 5 minutes, 10 minutes, 20, or 30 minutes, the longer the recording, the more likely there is to find drowsiness. Now we're going to scan back through the record and identify artifact, make a mental note. One can also mark it. There's one bit of eye movement artifact at 3 minutes and 19 seconds. Overall, the record is quite clean. We will continue scanning. We will see that there's artifact at 19 seconds. Again, that's eye movement at 19 seconds. And then we'll scan all the way back to home. This is an individual struck in the right parietal lobe by or the right region of his brain and skull by a bat, and he's resulting in pathology and a gross asymmetry with greater theta rhythms in the right hemisphere than the left. Now let's select artifact-free data. Click Edit, Automatic Editing. The Automatic Edit window comes open. The left part of the panel is for manual selection of a template of 10 seconds of data that does not have artifact, and then NeuroGuide will go through the remainder of the record and match 1-to-1 or 50% or 25% higher in amplitude with respect to the template. The second part of the panel over here is the use of a normative database that's instantaneous z-scores at every single point in time. In this case, a threshold of 2.0 means that if data is at 2 standard deviations or less, it will be selected. If it's greater than 2 standard deviations, it will be rejected. This is actually 3.5 standard deviations because of the within variance that is involved in the computation to make it extremely conservative. There's also pattern recognition routines to identify drowsiness, eye movement, and muscle artifact. One can change the sensitivity from high to medium to low. In this case, I'm going to go to the most conservative, which is high. I'm going to use the right side of the panel with z-score artifact to show that one can make 3 independent selections in about 30 seconds to 1 minute. If we start here, this in the middle section is the start time that we begin our artifact selection. In this case, it's going to be at 0 right at the beginning, and we're going to have a duration of 2 minutes of data. I'm now going to click Generate Edits, and I'm going to look at the edit time, which is 1 minute and 59 seconds of artifact-free data. Black means it's rejected. It could have been eye movement or drowsiness or even muscle. And I'm going to scan through the record. I'm going to especially go to the 19 seconds where eye movement artifact was present, and you can see by the black at the bottom it has been rejected. It's not accepted. I'm going to continue to go through the record, scan through the record to show that in fact no artifact was selected. I'm going to click the home key to go home. I'm now going to analyze this with respect to the normative database. As I can see, it's 0.95 reliable with 1 minute and 59 seconds. If I evaluate the z-scores, that is a comparison to a normative database, I see that the C4, P4, T4 leads are deviant from normal, and so is T6 at 1.87 standard deviations, C4 is at 4.26 standard deviations, and P4 at 2.83 standard deviations. I'm now going to save this edit selection by clicking Edit, Save Edit File, navigate to the subjects folder, and I'm going to save this as the first edit. I'm then going to repeat this by doing automatic editing. It is not necessary to clear the edits. We will simply now select a different sample of data. I'm going to go start at 1 minute now and have a 2-second segment of data. This is somewhat different sample of data, 50% different or more than my first selection. I'll click Generate Edits. I see now that there's 1 minute and 58 seconds. I will scan through the record to again verify that no artifact has been selected and that only artifact-free data has been selected. I will also look at the clinical interpretation, and I see that again it's the same. C4, P4, T4, and T6 are deviant from normal. Again, getting independent verification with an independent selection. I will then save this edit by clicking Edit, Save Edit. I'll call this the second edit. And now I will do a third edit. I will again click Edit, Automatic Editing, and then this time I'm going to go to 30 seconds. I'm sorry, 1 minute and 30 seconds. Well, let me just go to 30 seconds. I can just type in 30 seconds. And I will, in this case, select 2 minutes and 10 seconds of data. These are different independent samples. Now we get 2 minutes and 9 seconds of data. Again, we'll go through the record showing that no artifact has been selected, and I will determine that my clinical interpretation is the same, independently of whatever selections of artifact-free data I may take. I then will save this edit as a third independent sample, verifying that the artifact has been rejected and the same clinical interpretation is present with independent samples of data, and test-retest reliability is 0.97. There was some overlap of data in this case, but the record was short. One can verify you get the same clinical interpretation with longer records by simply shifting the start time for the analysis so you get completely independent records and come up with the same clinical conclusions no matter which artifact-free data that you select.